Hi, here we are in the BCIT PLC lab again. In front of me here is the L30ER PLC model from Allen Bradley. Next to it are several different analog and digital input-output modules. And on the left here, we have the actual model of an elevator that BCIT implements to teach students how to program a PLC. On here we have some toggle switches, an indicator light, a relay that can control the directions of these motors. You have a start and stop buttons. Down here is the inside panel that would be located inside the elevator for people to call which floors they want to go to. A door open button and door close button. Here we have an emergency stop button. And here we have this white strip right here represents where the elevator actually is. And along this belt, we have different optical sensors that can sense where this white strip is to let us know which floor the elevator is on. So they will be the first floor, and that would be the fourth floor. Here we have different buttons to call the elevator from outside on different floors. And down here is the model of the elevator door. Here we only have pneumatic actuators, so the door is normally closed, and a high output to this pneumatic actuator would open the door. So now I will demonstrate my PLC program on this elevator model. First, we have the initialization sequence upon the startup of the PLC. So the 3 toggle switches need to be turned on and the start button pressed 3 times. When the 3 LED on the top right lights up, indicating the elevator has been initialized. So firstly, I will just call the elevator towards individual floor. And now I'll demonstrate the door open and door close button. So if the door open button is pressed and hold, the elevator door will keep on opening until it is released, and after 1.5 seconds it will close again. And similar for the door close button, shortly after the button is pressed, the door is closed. So next I will demonstrate the situation where the elevator has to service multiple calls from one direction. So currently the elevator is on the 4th floor, and the sequence that I'm going to call the floor is going to be 2nd floor, 1st floor, and 3rd floor. And if the elevator follow my call sequence, it would go to 2nd floor first, and then 1st floor, and go back up to 3rd floor. But the program is written so that the elevator will always service the closest floor to its current floor first. So it will go to the 3rd floor, and then to the 2nd floor, and then to the 1st floor. Next will be the situation where multiple floors are called, but some are above and some are below the current floor. And the elevator will move in the direction of the first call that was made, and it will keep moving towards that direction until there are no other calls in that direction, and it will change its direction and service the remaining call. So currently, the elevator is on the 2nd floor, and if I call the 4th floor, and then the 1st floor, and then the 3rd floor, if the elevator followed my call sequence, it would go to the 4th floor, go back down to the 1st floor, and go back up to the 3rd floor. But it won't do that. It will go to the 3rd floor first, go to the 4th floor, and then go back down to the 1st floor. Next, we have the emergency sequence. You can see on the inside panel of the elevator model, on the top right, there's a button called PBE5. That's the emergency push button. And there will be situations where you want the elevators to stop regardless of all the other calls that were made. Like in videos you might see online where people got their pet stuck outside the elevator while the elevator is already moving up and they still holding onto the leash, and that can result in tragedies. So the emergency push button work by stopping the elevator in its track, and it will service only one call that can be made from inside the elevator. After the elevator has moved towards that one floor, the door will open and it will keep on opening until the recovery step is made in order to move the elevator out of the emergency mode. So you can see the ILE5 LED blinking red. That is indicating the elevator has stepped into the emergency mode. In the emergency mode, the elevator will move only to the first call that was made, and after that, it will not respond to any other calls. The recovery step is simply to push the start button once, and the ILE5 LED stop blinking will indicating that the elevator has stepped out of the emergency mode. And now we have the elevator working as normal. So here's the HMI that I created using advanced HMI, an open source HMI software that can be used to replace expensive HMI software like Factory Talk from Allen Bradley. Currently, advanced HMI connects to the BCIT PLC through Ethernet IP. So on the top, you can see the label of current floor that indicates which floor the elevator is currently on. On the left is the inside panel of the elevator. On the right is the call buttons for the elevator located on different floors. In the middle is the door open and door closed indicators that let us know if the door is open or if it's closed. So now I will demonstrate how the HMI that I created can be used to control the elevator model from afar, and also to monitor all of the states of the elevator model, like its current floor and if the door is open or if it's closed. Here we have the ladder logic program that I created in Studio 5000 to control the elevator. And as you can see, the program is divided down into different chunks of subroutines. Each subroutine performs its specific task. And the purpose of this is to make the code more organized, increasing its readability, and also helps people with visualizing the logic of the program. So first we have the initialize subroutine, and the subroutine performs the buffering of inputs. Inputs here refers to all of the push buttons, toggle switches, and also the sensors. Next, we have an important subroutine called individual floor called. These subroutines perform the arithmetic calculations that essentially tells the elevator which floors to move to first. So in this subroutine, there's an important variable named call. This is a shortened or 8-bit integer, and bit number 1 to bit number 4 of this variable corresponds to
floor number 1 and floor number 4 of the actual elevator. And the binary state of each of these bits represent whether the floor has been called or not. So 0 for no call and 1 for it has been called. And down here we have the different calculation block that help us to control the elevator in a way that in either direction the elevator will always move towards the closest floor that has been called first before it move on further to the next floor. So for example, if the elevator is on the second floor and there are calls from both the third and fourth floor, the elevator will move towards the third floor first and then the fourth floor and not the other way. So the most important subroutine in the whole program is definitely the state machine subroutine. And first of all, a state machine is a computational model that helps programmer to design a system where it has to transitions between distinct states. And in the last video, I talked about an issue that I had with controlling the elevator when multiple floors are called at the same time. And by implementing a state machine, I was able to resolve this issue quite easily, and also to implement a emergency sequence into the program. And currently, you can see the state machine subroutine, and it's quite long. So I will just show you a simplified state diagram without the emergency sequence, so that you can see how I developed this program.
Okay, so here is a simplified state diagram that represents my program in the PLC. So upon startup, the PLC will have no state, and you need to perform the initialize sequence to move the program towards the initialized state. And the last step of the initialize sequence is to press the start button. So I use the release of that start button to move the state from initialized to idle state. So the elevator will never stay in the initialized state for too long, because pressing and releasing the start button will move it from the no state to the idle state. So from the idle state, the elevator can either move up or move down. And the conditions for the transitions from that idle state to move up or move down is, let's say, a floor above the current floor that was called, or the floor below. So let's examine the situation whether it's a floor called above the current floor. So the elevator will start initially moving up. This is the initial move up state. And it will continue moving up until the next condition is reached, which is the floor has been reached. After the call floor has been reached, the door will open, and there will be a timer that control how long the door is going to stay open for. After that timer has been finished, the door will close, and there will be a different timer that controls how much time has elapsed before the elevator can continue its state transition. So we don't want the elevator will start moving right away after the door has been closed. We want a certain amount of time before a certain amount of time after the door has been closed, and then the elevator can continue its moving sequence. So after that closed door timer is done, the elevator has two choices. If there is still floor called above the current floor, the elevator will continue moving up. This is the continue move up state. It will continue moving up until that floor has been reached, and it will go back to the door open state and door closed state. But if there's no floor called above the current floor, and there's a floor called below the current floor, the elevator will move to the initial moving down state. For example, if initially the elevator is on the first floor and it was called to the third floor, after it has opened its door and closed its door, if the fourth floor is still called, it will move towards the fourth floor. But if there's no call on the fourth floor and there's call on the first floor, it will start initially moving down to the first floor.